5 reasons that maybe it's time to switch to a distributed database if you haven't already pulled the trigger on that. We're going to talk about what are some key factors going on in there, and what is it about distributed databases that is, why do people reach for them? What's the angle on all that thing? You know, I was kind of thinking about today's topic in presenting it, and it kind of took me back to when I started my career as a pro coder in writing software. And I was rummaging around looking for a photo of like to kind of capture the vibe back in the late '90s, and I kind of found this one. A friend of mine had captured it when I was on the driving to work, and this is what it was like back in the day. Back in the '90s, we had to kind of fend off the dinosaurs and all that stuff, and just another day at the office. Okay, that was silly. I went to AI and said I need this picture, and it said here you go. But in all seriousness, what we're contending with is there's characteristics and applications in our data sets that we're battling, that probably you may be struggling with every day. And the first signal that maybe you need to be going to a distributed database is are things just getting too big? Is your data set growing wildly? Is it going, in directions you didn't anticipate when you got started? We're going to switch over to this. And we've been doing a little bit of this in the past with our nice little tablet here. Okay, we got our thing here. Let's go. I want to get some colors here. Let's get the so you got your one table that's got, you're managing whatever your business is, you've got transactional data. Maybe you're managing orders or something like that, and so maybe this is your order table or something like that, where your orders are coming in. And maybe when you started off, you had an idea in mind about, well, this is the kind of volume we're shooting for in data to come through the system. And so in doing your little sizing analysis, you figured out, well, we're gonna have 100,000 rows or 1,000,000 rows or something like that. And what's actually happened is it's, maybe it was a lot more successful than you anticipated. And so it's a huger volume. And then you know, maybe the orders table isn't the one that's so huge. It's, in fulfilling the orders, you now have people that have purchased your product, whatever that is, and now they're interacting with your system. They now come to your system to access what they purchased. And the volume of that is what's gone off the scales. It's grown way faster than you anticipated in. We've had, in the past 10, 15 years, we had big data. I remember when Hadoop was the rage. And so we had to jump off. Did I lose that? Well, let me see if I can fix that. Da, 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 da. Okay, here we go. Okay, I'm like, get back up there. Okay, so that was the idea, was people were purchasing products, multiple locations, so there were orders in the system. Maybe the orders isn't this big, but then you start having this flow of data coming in where you're tracking where your customers coming from. Every time they walk into a store to purchase a product, who's buying what and where? What's the traffic like? Oh, look, we're selling 30% more of a product at that location than at this other location. And you've got some kind of this is my nice Monet artwork of, you've got different data centers here. So, you've got data centers all across, or not data centers, you have locations with your product, and they're all interacting with each other. And people are coming in, it's like, oh, look, the sales at this location is up 30%. Sales at this location is down 20%. But on certain products, so you're figuring out, okay, where do I have my distribution? Where am I going to send different products? Okay, I need to get more product to that location. I need to slow down the rate I'm going to other places. So in a sense, there's a certain velocity your data possesses. There's a certain rate that data is coming into your enterprise, and it's filling up tables. And this is where your data set is let's zoom in on this one here a little bit. Let's zoom in here. So you have these transactions flowing into your system. You had to alter the schema multiple times. You added more columns because there's more data points. You're getting geographic data. SKUs from your products are filling up the tables. Every time the one of the tricks that you learned in discovering how your business operates is that you have to operate funnels. You have to sit there and track. If I track when somebody looks at a product, when they buy a product, and when they don't buy a product, and when they abandon shopping carts, this kind of phenomena, you're able to get insight into what people are interested in and not interested in, and you can invest more heavily in key things and try to pick up trends. But the only way you can do this kind of business analysis is if you collect all the data. You need to be gathering every point of data and filling up this table as much as possible, and then sending your data analysis team after it. So this, what you started with sizing your database with, turns out to be you didn't buy a big enough database. So things are starting to get too big. And what are you going to do with that? Great question. And this is where there's something to elaborate on here. This is where things like distributed databases may serve you, because distributed databases are built to scale. They're made to be able to grow, and instead of thinking back to the very simplified, okay, I'm going to go to my data center where I've got everything configured. I'm going to the data center and I'm expanding these web servers. I got these different web servers or different app servers, whatever stack you're using to build the application on. You're sitting there working with that, but you have this nice, pristine, centralized database server sitting in the corner in the server room, and it's over there, and people are interacting, and all your apps are flowing or are linked up to it to be able to do this kind of analysis. So whether you're flowing data into the database, you're reading data stuff out of the database, it's the nerve center of your operation, of what you're figuring out what to do. And what you start uncovering in this thing is the fact that there's different angles to this data. Okay, I put this one up here. Uh, okay, yeah, let me put the right map up here, and let's put this one back up here. So you've got your map with the layout. You have all this different data, but I just mentioned, here it says product up 30% in the top right corner, and the bottom it says minus 20%. But that may only be certain products. On this particular depiction, the one that is increased 30% is on the eastern seaboard. It could be in wintertime, some of the products that your store is selling is something that's pursuant to the weather conditions on the eastern seaboard. So of course it's real popular. But your facility that's out in the southwest, in the desert, effectively in the desert area, that product is not of interest to the customers out there. That's why that product is down 20%. But what if there's something else, you know, at that location? Let me get on the right layer. At that location, but you have plus 40% of other products. And again, over here, other stuff is minus 25%. It's now become multi-dimensional what you're looking at, what you're trying to figure out. You're trying to figure out which product is selling how much at where, what do you need to do? And this is where we start getting into a much more complex thing. And you're like, wait a minute, this is not as simple as I imagined it when I got started. And this is where you start discovering that things aren't one dimensional. It's not just a factor of, okay, the data itself is complex, it's nuanced, it's detailed. And the other thing is I can go back here to to where I was drawing some simple tables. I need a more complex diagram, okay? Now, at first, let's see if I can. Okay, I'm going to draw a little bit smaller table. So you've got, maybe this is all your transactional data that's happening. So you have this table. It's growing in size. You have, maybe you have sales or something is you're tracking here. It's growing in size. I'm trying to use some color to make it a little easier to follow here. So let's pick the sales. Sales. Okay, this is This is a different table that's growing in size. You have now another thing, order fulfillment. You've decided, you cannot ignore the chance that you're not just selling in locations. People are actually going onto your website and ordering your product virtually. And so you're having to start ship stuff there. So it's expanded your reach. And so your order fulfillment system is growing. And the whole thing is there's an element of if I take the growth of this table on the left, multiply it by the growth of this table, and multiply it by the growth, I'm going to get a huge markup or a huge increase in the volume of the data. It becomes multiplicative. And so here's one dimension that your database that your database is growing in the capacity that it needs. It's like, well, gee, it's growing faster than I expected on every table, so I have to multiply them together, and it's a compound effect. And so it's like, is this cluster big enough for what I'm doing? Now, this is where for years we've gotten away with buy a bigger server, go provision a bigger thing. Just okay, I bought the U2 size unit from my favorite cloud provider. Let's just slide it over to a U4 and do that. Okay, well we've been able to do that for years, for decades. That has been the go-to solution. But people are running into situations where that doesn't work anymore. That's not enough to just get a bigger server because we've got some more complex situations happening. For example, let's go back to our map. Okay, let's go back to our map. Now we talked about the complexity of your data here. All right, come here. Okay, so we talked about the fact that you have different product sales in different locations. It effectively turns it. You start to discover you have regional level data because you know there's more cold, wet environment here, whereas out here, hot and dry. I mean, what am I talking about? What is Greg talking about here? The fact is, in different areas, in different regions of the country, there's different characteristics. And if the product you're selling, there's some products that are more aligned with a cold, wet environment versus a hot, dry environment. So your environment has become regionalized as to what products you need to do. And if you don't adapt to it, you're scrambling to catch up to that, to deal with this fact. This is what lends itself to this differential. It's not plus 30% on the eastern, it's plus 30% on the East Coast for mitten sales. Like the sale of mittens has gone up 30% and you didn't foresee that, so you're having to scramble to support that. Whereas the sale for mittens in the desert is way down. In fact, you probably don't need to have it there. Okay, maybe there's one pair in your entire store in case somebody strolls in to get that, but you need to have two end caps loaded with them on your location on the eastern seaboard. Okay, that kind of thing, where you're having to deal with that. It's become regional. Now, there's other businesses here. I've been talking about like a simple basic store product. The idea is I can take this concept and expand it and go in other directions. Okay, fundamentally, let's draw another awesome high grade artwork map of the United States. And this applies whether you're in Europe, United States, Asia, you name it. What if your business though is aimed at a different market? In other words, you're a bit of a broker. There's a lot of services where people are essentially connecting consumers, your clients with certain things, certain, some kind of I don't know, a meal delivery franchise, if I could draw it correctly. Okay. Um, I don't know. That sounds like an interesting idea. Well, there's people that want your service. Okay, there's people at every location. So if you're tuning into this on the audio podcast, then which hey, you should be doing if you're not. Um, I've drawn a map of the country, and I've drawn three different locations, and I have three different hungry customers located at each location. And at each one of those locations is multiple businesses that can feed that person. And so that's what I'm drawing. Little like Monopoly type houses. So what we're talking about is the fact that your data isn't one dimensional. It's not just that everything's bigger. The tables are bigger. That's the whole scope of it. That is not the whole scope of it. I want to be very clear. That is not what the entire problem is. The thing is now you have the phenomena where your whole business is I'm trying to get the color right on this thing. Okay. The idea is I've got a customer on the West Coast, and I want to link them up with three potential businesses here that they can get the product. Like I'm building my business links them together, and then I get a small piece of the commission, or I get a small fee for doing that. So they can link up with here, and then the person who's in the Midwest, I'm offering them the businesses there. I got a couple businesses there, and they're linked up. And then finally, the person on the East Coast, I'm going to link them up with their businesses. Now, do you think it's a problem that the person on the East Coast wants to link up with the business on the West Coast? No, they don't want that. They're trying to connect to a local business that's going to provide them a tasty meal, and they probably want it soon, not 12 hours from now. So there's an element of when your data gets big enough, you run into this situation where you need to be able to segment your data. You need to be able to divvy it up into this regional nature. And this is a strong reason to go to a distributed database, because distributed databases do this kind of thing for you. They help you with this phenomena. And so this is not a problem of, okay, my tables are just gotten bigger. I have more volume than I ever expected. I'm just going to buy a bigger server and solve it. The bigger server solution doesn't help with this. This is something you've got to either you're going to do it by hand yourself, or you need to turn to a solution that can do it for you. And so you just need a way to do the cost benefit analysis to figure out whether that's going to serve you or not. Okay. And this is an example how when you go into expand, it's not just a one-dimensional aspect to it. There's other characteristics, there's other dimensions that you run into. My awesome Monet artwork here of the United States, where maybe I'm not a food broker. I'm doing something else. It's still nationwide, but maybe I've got my servers on the East Coast, but I want to handle in case something really bad happens. What happens if the whole East Coast goes down? I may be running on a cloud server or something, and they have a regional outage. I would really like if everything could just magically hop over to a backup location that's maybe in another region and go to green. Okay. And in this case, I need to handle the fact that there's physical impact with doing that. We need backups, and oftentimes some of the stuff we talk about, I need my database to survive an outage. Okay, that's a pretty simple thing to say. I want my database to survive an outage. Great. We've talked about that before on the Select show, but if you start to peel the layers on what that means, it gets complicated. It gets complicated, at least if we're going to talk about doing it yourself, doing it DIY. The problem here is that well, what do you do for the person what do you do for the client application here's my awesome artwork of somebody on the West Coast, a little stickman figure holding a smartphone, and they're connected to the application. Okay, the application talking to the enterprise. Well, it could be. Let me back that up. Let me here reset. Let me start with the customer using the app was on the East Coast. They were initially talking to the server in the East Coast. Okay, the server is located in the East Coast, pretty close by, pretty effective. But suddenly there was a cloud outage, so the enterprise failed over to a backup server in the Midwest or maybe further away, and suddenly your physical distance to reach the server just doubled. What does your app do in that context? How does it handle that? What is its response to it? Can it handle doubling the latency like that? I don't know. We had a whole episode about that. In fact, there's actually a blog article that we discussed about that as well on the Cockroach Labs blog site. But I actually sat in on a meeting where we were talking with the customer, and I was charmed at the fact that the speed of light entered the conversation. We're discussing the speed of light because if you're going to talk about whole regional level failures, and maybe the East Coast is where your principal cloud setup is, but it fails over the West Coast. What do you do in that context? You need to be able to handle that. It can't just be summarily wrapped up with I want my database to fail over. It's a little more complexity than that. So this is a reason why you may need to entertain going to a distributed database, a database that actually has some semblance of what to do in that scenario, where you can at least look at all the trade-offs. What are the trade-offs to this scenario where you fail over from where you survive a regional cloud outage? Most of the time we like to, I don't know, we're prone to sit there and think, I hope it doesn't happen. I've got some backups, but we don't, are you testing the backups every week? Um, I actually worked on a contract where they had emergency. Let's flip to on this contract. They had emergency power generators hooked up to the building, and actually every Wednesday at noon they tested them. They cut over. I didn't know the details. They essentially cut over to the thing to verify it worked. It's like, is the thing even operational? I had seen instances of tape drive backups used. This is 25 years ago. They're using a tape drive backup. It was supposedly doing backups of all the servers, and then we had an actual outage, and they went to the tape drives, and the backups weren't there. What do you do? You need something where you're actually testing it, verifying it. You need to have a game plan. It has to be more than my database survives an outage. Okay, what does that look like? What is that? What's the plan for that? Well, does your database have all the primitives and the operators needed to manage that? Do you need to double your staff that's maintaining your database to handle that? On that contract I described, where they had the backup generators, I believe they had a um, a top level software engineer managing a team of 6 database administrators. Um, and fundamentally, they always had one of them. Somebody was on call, coming in at any time necessary to deal with that. Okay, it's 6 database administrators. It's the biggest thing I'd ever seen. And so that's some of what you're contending with, and the fact that when you go to a distributed environment, it's not a one dimensional. You're not correcting for one circumstance. Okay. Now, before we go on to number 3 that we're coming up with, because we're talking about 5 reasons, and we've just covered 2 of them for going to a distributed database. I do want to remind you to go check out university.cockroachlabs.com. You can actually get an opportunity to take CockroachDB for a spin. You can check it out. Now we have a lot of material in there. Some of it's readily available. Some of it you need to sign up for our subscription. And you can check it out. It's chock full of solid content, and it's great. So I encourage you to go take a peek at university.cockroachlabs.com. There's another aspect that we need to look at, and the thing is, it's frankly time to stop thinking about it. Either your server is either active or it's passive. We're familiar with the concept. I hope you're familiar with the concept of, okay, I've got a database server. The thing's active. What happens if it dies? Well, I've got another one I've got the same model box sitting right next to it with the same software. It's synced up, and it's passively sitting there waiting to cut over to it in case something goes wrong. That's an active passive configuration. Well, we've seen that stuff doesn't happen quite fast enough. Oh, hey, we got a comment. Let's go ahead and throw this up. Clifford, thanks for coming to the Select Star show. He says the online enablement at Cockroach is quite good. I'm glad to hear that. I'm glad you're enjoying that. So, and thanks for coming by to check out the show. So, the cutover time, I remember initially when clusters would fail over, and it was like, oh, 2 to 3 minutes will be up. Well, they realized that's not fast enough for database. That's certainly not fast enough for a database. Maybe a web server or something like that. I don't know, but um, so they started coming up with faster ways that they could have another server take over in the event of a calamity ensuing. Um, and so they came to what's called active-active, where basically they're both servers are running, both are reading it, and it's really just a matter of it's flipping a switch, and all the network traffic flips to the other one. There's an element of they both of these servers have, like, this is server one and this is server two. And there's a virtual address of just server, you know, database server, and this is database server dot one, this is database server dot two. And essentially it's just like a load balancer, it just flips between the two. Okay. So in that case, you're running two servers. It's in some kind of active-active configuration, and I don't know if that's even what the latest is doing. They keep coming up with newfangled versions of it, but it's kind of the same concept, to where you're running one server is doing the work. One is the workhorse. The other is, in a sense, it's spinning wheels and consuming bandwidth and eating up your cloud budget, but it's not working for you. It's working to keep itself in sync so it can take over, in a literal second or maybe less. Okay. So you're essentially running at 50% usage, like a mirrored RAID drive or something like that, where you're physically, like, I'm purchasing double capacity for my disk drives and mirroring it in case one disk drive fails, because that's a for real thing that happens. So this is what an active passive mindset is like. Okay, let me let's go. Let's take a peeky look at what that would be like. Okay, so essentially, big server with big server next to it, with a big pipe connecting to the two. This is where I've seen the 10 gig networks, the kind of fiber. We're going to talk about fiber. Let's make it double, extra. So in other words, no bit is going to be missed between these two. These two suckers are in sync, okay? And we're not talking about the band. Okay. So this is active. Remember, what was the other thing we talked about way back on bullet one? It was buy a bigger server. Buy a bigger server. So here we're talking about, a big towering server. And if you can't see it on the podcast, I drew a stick man that's a quarter of the height of the servers. The idea is you've bought this jumbo server. It's probably one of your biggest ticket items that you bought because it needs to handle those growing tables. We already talked about growing tables and the multiplicative compound factor. So you bought a bigger server, and in order to handle failure, you bought two times two. So now you got two servers and you're operating at 50% utilization. Now, I don't know if in these active situations today, the way they've gone now, if they're actually having it where they're both working for you in some. Here's the risk when here's the struggle. The struggle is real. The struggle with, okay, I don't want to pay for all this hardware, all this bandwidth, all these megaflops, if people still use that terminology, and I'm only using 50% by definition of that hard. I want to use all of it. I'd like to be using all of it. Okay, so is there an active configuration where they let you invade part of it, so you're using more than the 50%, using 75% or whatever? What does that look like? It's like, are they doing that? I don't know. It's getting kind of edgy, because now you're at the point where, well, what is it doing? How's it handling how's it syncing up changes between them? If there's not one single server responsible for maintaining a given table, what's it doing? That's where I'm prone to think you're juggling stuff. Now, I want to remind you, if you're enjoying this content, if you're getting value out of this, then I invite you to hit the subscribe button and ring the bell, so that way you don't miss our future upcoming episodes. And also, you can look for the show on your favorite podcast provider, Apple Podcasts. Well, Google Podcast is no longer a thing, but there's like 101 different podcast providers. Whatever your favorite one is, go look for Select Star Show, and you can sign up for it there and tune in. But the idea is, if you go to a distributed database, it's a different game altogether, because now it's essentially, I've got server nodes throughout the enterprise, and it spreads the load across all of them. There's not a scenario in a distributed database. Let me type this, let's write distributed on the page here. A distributed database where I'm using all the servers, because the idea of somebody being active and somebody being passive is gone. Okay, it's not there. It's distributed. In a sense, it's not like they're all primary or they're all replica, or they're who's primary? I don't know. Is he primary? Is the first one the primary one and the others are mirrors? That's the solution with a single primary database server coordinating all the changes and then distributing the updates to all the other mirrors is a tacked on solution for monolithic solution database. This is not what distributed databases do. The whole idea of a distributed database is all of these nodes are equal in function. Nobody is primary, nobody is secondary. They just are. All these nodes are here. All they're coordinating is how do we divvy up the database? We can talk about the old school solution of sharding, and this is something that happens when we start talking about, especially the database you just can't kill, is that people say, "Where's the shard key?" Sharding, like that kind of manual level management of divvying up of data in a database environment, is kind of a bolted on solution. So what Cockroach DB does is it does it for you automatically. There's no contending with what's the shard key. Hey, Clifford's got some more comments. I love this. Many active DBs do allow transactions on all servers at all times. They rely on fast shared storage. I bet. And this is the game we play in engineering. Everything's trade-offs. We got to check the trade-offs. And so my curiosity is, I don't know where the evolution of the state of this stuff is right now with active DBs on monolithic systems. So this is the market pressure is, okay, they heard the word, nobody wants to run on 50% utilization. So, well, we need to start using them. The database is where we need. Why do I need a bigger database when I've already got a spare sitting right there? So this is BABS, but I don't know what that acronym is. Well, I assume that's what you're talking about. These active tend to be a bit fragile and require advanced skills to manage. And I'll bet you what you're using is sort of a I don't know, premium feature. Not every outfit is probably using that add-on or that characteristic feature. So you run into who has the knowledge on that tool, who has that knowledge on that add-on feature. I don't know. Yeah, buy a bigger server. That's your solution. Is get the bigger server. Okay. That's the thing, and it was always a matter of, well, how deep are your pockets? How far can you go with it? Well, there's a certain, this is what feeds the characteristic of a lot of the shops that come to us, that come to the database you just can't kill, or like we've already played that game. We already scaled. We went as far as we could with active. We've reached the point we need the regional stuff. You remember we talked about distributed isn't one dimensional. Distributed is not all about bigger. It's not all about bigger. There's the cloud solution extended the runway people had to say, I'm going to buy bigger. I can buy this virtual cloud that under the hood it has who knows how many gobs of CPUs. I don't know. There's 120 CPUs inside this virtual server. It's like you can't physically rack that, but we can make it look like that from a cloud solution. So you got it. We've got you. As long as you got the money, we got the server for you. It's not all that. Which one of these has the One of these has the yeah. It's the regional solution. Remember, it's you run into regional situations where my data is more nuanced than that. It's not just a lot of data. It's a lot of data with very strong regional based context. Now, this is what I've put up here on the diagram is geographically regional, but there can be other logical distributions that also need this feature, this regional characteristic. And I just this one's to me is easiest to grok. And so I run in, that's trying to see if it's showing up. Yeah, there's a little hand showing up here. Okay. So anyway, this is what you run into. It's like it's not all about, I said it's time to stop thinking about active or passive or this is why we go to it's distributed. And the whole thing is there's like it's almost like you have to stop and it's almost like you have to take what you know about physical infrastructure management, about database management, and kind of just set it to the side and say, there's a lot of assumptions we run on. I mean, the biggest thing that I had to come to grips with is it's weird, but I realized I had understood monotonic sequence counters for primary keys. That's just like textbook. That's like everybody does that. You have tables. You need to guarantee you've got an opaque guaranteed primary key. Nobody outside the database has to even know about this key necessarily, but it's the building block to have consistent acid-based tables and have it be performant is you just got a nice little sequence counter that increments for every row that you're inserting. The value always rises. It's monotonic. And that's what that means. And that's what we use everywhere. And when you walk into a distributed database, you need to take that idea and throw it out the window because that was basically a rule of thumb. It's a rule of thumb that works in a monolithic database, and if you stick with it, it gets you in trouble in a distributed database. We talked about that in a previous episode of Select Star Show, so I'm not going to dive into it. That's why the recommendation is, if you can, switch to UUIDs. They have a lot of key characteristics. They essentially act like hashes, which means it's a randomized set. It will automatically distribute the rows across this distributed enterprise. Put it back up on the screen here. Let's put it big. It's going to automatically distribute. The first write's going to go here, the next write here, then here. Just this is at random because UUIDs themselves are random. I can't answer the question. It's not fully random because nothing in computer science is totally random because that's an unsolved problem. But essentially, it's going to randomly distribute the rows across the enterprise and avoid something we call hotspots. If you gang up too many writes on the same server, if you have all these writes coming into the same node, we call that a hotspot. Because now what could be spread across the enterprise is instead all being queued up on one. And that's what happens if you have a sequence counter doing that. There's ways to ameliorate that with hash buckets if you can't change your schema. But if you're able to build a fresh table and use UIDs, they're great. There's another characteristic, they're locally generatable. So there's no need to go back to somebody that's holding a sequence counter. The other thing is the sequence counter was implemented with atomic counters. It was possible to sit there and say, nobody is getting the current value of the sequence counter twice. We're not going to have two copies of this same value go out and accidentally get into two different rows. That would violate our ACID properties. And the whole reason we're going to SQL is we want the ACID properties, okay? So the idea is that there's some sequence counter that's got to be managed and you go distributed, but everybody has to go back to a central server to coordinate the change. It kind of breaks the point of distributed. So we need something that's locally generatable, and that's what UIDs do. So again, something that that I'd assumed that I understood from the ground up for years. I have to admit, decades. I've known this for 25 years, is that we need monotonic sequence counters, not distributed. You go to distribute, you need to let that go. There's some other habits that we have or other rules of thumbs that we operate that now we've assumed maybe just by habit we assume they're law, but they're not. They are applicable in monolithic, and sometimes they're not applicable, or they actually get in the way and are counteractive to you when you go to distributed. And this is why you need to be willing to invest time in learning SQL. So sometimes we have people that come to us, they've got huge systems and they need to migrate to distributed. They've got regional data, they've got their tables are growing. They need more systems. They really don't want to go down the buy a bigger server solution. Okay, they would they would be more effective if they could spread the load in a more geographic sense. They're like, okay, we got customers on the West Coast that need West Coast stuff. We've got people on the East Coast that need East Coast stuff. We need to distribute the load. We need to spread the data across it. We don't need to have all the data for the East and the West mixed together in a double-sized server and replicate it both places. Instead, we need East Coast and West Coast to be in their own area. And it would really be nice if that happened automatically. Like, what if you could look at the zip code, or some other? If you're in the, I don't know what a counterpart for zip code would be in Europe, but you get the idea. We need something that's geographically based. It can automatically distribute itself based on map data, and from there, the customers on the West Coast talk with the West Coast data, and the customers on the East Coast interact with the East Coast data. So before you can take all that on, how good are you at writing SQL? Are you kind of sloughing by? There's a lot of I'm gonna say anti-patterns out there. The anti-pattern movement was kind of a big thing for time. I don't know if people still talk about anti-patterns as much today, but there's a lot of people that are, well, I got this ORM tool of mine. It's going to help me out. I'm just going to go. It makes it where I can real quick throw a persistence layer on top of my database. It'll read the schema and automatically give me this object. It's going to let me fetch out the rows of the table. I'm just going to fetch the table and I'll let the application filter out what it needs. So that way I don't need to talk SQL. I don't need to do SQL. Well, there's systems where you can get away with that. And then suddenly your system starts growing bigger, bigger, bigger. You went and bought the bigger server, but your app, it brought your app to its knees. Because there's a certain point where you need to say, okay, when I first built that, there were 100,000 rows in the table, and that was okay. Maybe it sent 100,000 rows of data over the wire, and maybe that wasn't horrible. I don't know. Maybe it was 10,000 rows, something like that. It was a small data set. You could send it over the wire and let the app filter it. Or the app was on a server sitting next to the database, so that was not expensive. It traveled from the database server to the app server. The app server could apply the client's filter criteria and finally send it to the app. But now your database system expanded to 100 million rows. That's probably not a good idea anymore. So some of these handy tools that we have, we have ORMs, we have stuff to help us write SQL, they're really powerful. You can get off the ground, you can make the screen, you can build a web page, especially with those AI coding tools. I'll confess, they make it real easy to get on there and make that web page wiggle for you somehow. And then you realize, well, I need to hook it up to a database. I need this database persistence layer to come back and give me data. I got it on the screen. I'm building a filter. And you need to pause because you need to make sure you're writing the right kind of SQL. I once attended a presentation by an architect, and I really enjoyed this one summary message the person had, and it was, you can't build skyscrapers with doghouse building tactics. There's a lot of demo apps, proof of concept apps, way too many that you show it to a program manager, hey, here's my proof of concept, and they're like, okay, how fast can you get that into production? Give me a week. Okay. There may be some tactics used to make it work, make it an MVP app that you roll it out there and it's like, well, it's functional, but now once you start getting into real production data, there are some pieces that probably need to be rewritten. Now, maybe you're thinking, well, the HTML I wrote was a little sloppy. Let me fine tune the HTML. Let me get some better style sheets. Let's make it responsive so it looks good. Some of our clients have mobile phones, or 60% of our customers are using the mobile view. So let's fix that. How many times are you going back to the ORM layer and saying, I need to rewrite that query, or I need to go look and analyze that query and run an explain plan on it? Or how much of that effort are you doing? And this is some of the stuff we have, like in our training content, we have like a whole day's worth of training on this to get kind of a fundamental paradigm across to you. If you visit the university.cockroachlabs.com, we have this performance tuning course that you can grab. And there's an idea you need to if you're going to write select statements for any enterprise, monolithic, distributed, whatever, we need to write good SQL. We need to write good operations. ORMs have made it tough to stop and say, I need to write better queries. But we need to learn how to write correct joins. We need to make sure we're hitting the indexes. I mean, in previous episodes, I talked about how we actually broke or evaded an index because we uppered a column, something like that. So you need to be writing good SQL. And when you go distributed, because you can't remember, distributed isn't one dimensional. Okay, there's different aspects. The tables are getting bigger. Your data may be regionalized, and your everything's just getting bigger. So when it comes time to write those regional queries, you need to invest time in learning how to write good SQL. Okay, this is an important aspect, and it's something that you may find yourself catching up on and realizing, well, where's the hiccup in the app? I mean, I had seen a business app that was being used by the business office. These are people that worked Monday to Friday, 9 to 5 kind of thing, and they weren't the part of the critical keep everything running type thing. They're people that came in and provision stuff. They had a query that took 20 minutes to run, and there was no reason for that. They didn't have anybody stop to look at it. The person who had written that was no longer there. I took over the app and found out it was the number 2 most costly query running on the database, and that was a database that had reached 100% utilization every day at noon. And they were meeting to figure out what was going wrong, and they were looking at query number 1, which was the operational stuff. Query number 2 was that business query I just talked about, and I had that. Now, I wasn't in the meeting. I happened to walk by and notice that, and I went back to my desk and started tearing that query apart. And it took me, I think it's something like 5 weeks for me to figure out what it was doing, how to rewrite it, and it went sub-second. If you're going to go to a distributed database for all the other reasons we've been talking about in this episode, you need to invest the time to learn how to write better SQL. It's valuable to invest in yourself, invest in your team, have them do training courses in order to improve that, because you really need to have the methodology in place if you're going to be distributed to take charge of the asset you've provisioned. Which leads me to the 5th point about, is it time to go to a distributed database? The thing is, you may already be running a distributed system. Let me go back to my high quality artwork here. Let's see, is it this one? So this may already be what you have, what's already your existing enterprise, and you're holding it together yourself with scripts and tricks, and you have staff that they're running reports. They're like, we need a report to figure out, data builds up over here and it's over there. And sometimes when you can't, it's like, well, we try to run this, we need this regional query for the West Coast, but when we run it on the main table, it takes too long to be practical. So they've engaged in a little data denormalization. They have an auxiliary table that's related to it or is a subset of that table, and they have triggers or whatever set up to try to maintain it. And so they're like, and they're writing application code that says, if we detect your IP address is on the West Coast, we're going to route you to the other query that uses the West Coast auxiliary table to find the answer. That's great. That's very clever. That's that's a neat trick. But a friend of mine who was on the Spring team as well, he had a neat saying. It was like, I don't like cute solutions. I don't like tricks. I want something that's straightforward. And if you have to use tricks to make your system operate and be performant and deal with this kind of regional level requirement that you've got functionally operating, that may be a signal that you really need a grade A first class distributed system, a distributed database, like the database you just can't kill. That may be what it takes. So stop and check it. Are you running a single app server, a single web server to power your entire enterprise? This thing has 5 locations. If the whole thing runs on a single stack, maybe you're fine. But if you've grown to where, well, gee, I have a half a dozen web servers. I have 3 app servers. I have several load balancers to manage it. If your infrastructure diagram is getting complex, let me turn this off. Basically, if I've got all these web servers, maybe they're spread out in different clouds, but they link up through load balancers. And you've got one app server in every region, and this all is linking up to your jumbo active database server. This, if you're starting to look at this kind of enterprise configuration, well, shoot, you're already running a distributed system, okay? You're already having to contend with that. But what you're having to do is, instead of, what's the proper sizing of the team? Do we need one app developer, a sysadmin, a DBA? Is this the team, or am I having to? Do I have 3 app developers, and I've got? How do you draw this stuff fast? Do I have 4 sysadmins, and I need 3 DBAs? Am I having to, run a huge staff in order to hold this thing together with baling wire and WD-40 or something? Is this what it's taking to do, to run it on the cloud? So it's like, it could be I could pivot to a distributed database, and maybe the physical devices aren't going to shrink, okay? I may need this many devices, but the idea is I'm having to strap everything together. I'm having to glue things. People are having to write custom code. It's like, I refer to this as this is an out-of-band solution. You're running a distributed system if it's really this complicated and you need this level of staff. Now, you could be running a big system that's not really a distributed, but you still need a lot of staff, but based on sheer volume. But you can take this diagram and just add a 0 to both sides. If it's simple to say, well, I don't want to oversimplify stuff. If it's like, okay, you go to your development team. Instead of 1 person on the diagram, your team is 3, okay? And you say, I need to add this feature. Okay, we can do that. That's a web feature, or they know who to go to. They can roll it out with ease, or with reasonable effort. Okay, sounds good. But if they're having to do this brainstorming conversation, say, well, we're going to need 2 or 3 design meetings. We need to figure out where we're going to fit that in, because we have these scripts that route different requests to different places, and what you asked for is a new type of request. So we need to figure out, does it fit into a current branch, or do we need to add a new routing mechanism? When you're starting to do that, then it's like, well, now you've got a distributed system, and you've got multiple people gluing it together to hold it together. And that may be a reason to say, I need to upgrade to something that's going to work with me, not against me. And that may be a very valid reason to go to a distributed system. So now if you enjoyed this discussion about 5 reasons that maybe you need to go to a distributed database, then smash like and let us know you're getting value out of that. In the meantime, I look forward to seeing you in the next episode.
This episode is over, but your learning has just begun. Visit cockroachlabs.com to find all kinds of content to expand your knowledge.